Hi students, welcome back to my channel Ultrasound Whispers. Today we will discuss a very important topic about units and their conversion. We will also discuss scientific notation that how these units are converted into one another. So this topic is very important. You will encounter number of questions in SPI exam, and today we will do a lot of we need a little know-how of math to solve the different questions that are rendered in SPI examination. So if you are ready, then get your calculator ready. Here I want to tell you that in SPI exam they will not let you use calculator. You need to memorize some values and conversion ratio. Let's see how these scientific notation work. Scientific notations actually is a way to represent a quantity, and from quantity we mean a frequency, wavelength, time period. In physics, to represent these quantities, you always need two things. Number one, a number, and other is a unit. Wavelength 2 millimeter. Time period 3 microsecond. So in all these representation, it comprises two things: a number and a unit, a number and a unit, a number and a unit. So scientific notation is the way how to represent a quantity. So today we will practice that how these quantities are represented, and what are the units, and how can we convert larger unit into the smaller unit. So basically scientific notation is a mean to convert a large number into small one and small into large. So in scientific notation, uh, as I told you that a very large number is concised, and it is also called engineering notation. Let's see the conversion that to convert a large value that is greater than 10, move the decimal from right to left and multiply the number with 10. 10 decimal means the number 10, and put the power of 10 with the number of count. You moved the decimal to the left with positive sign. We will see a little bit later. And if you want to change a value that is less than 10, then what will you do? You will move the decimal point from left to right, and you will multiply the number by 10, and you will put the power of 10 with the number of count. You move the decimal to the right with a negative sign. Let's see how. So let's see that when our value is greater than 10, so this value is greater than 10. So what, and here is your decimal point. So to convert it in a short notation, so you will move your decimal from right to left. So let's move 1, 2, 3, and 4. Now 1.0 multiplied by 10, and the exponent of the 10 will be the number of count that you have moved your decimal towards left, and you moved your decimal 4 times. So the value of exponent of 10 will be 4. As you have moved your decimal from right to left, so the value will be positive. You can write this like 1 into 10 raised to power 4 or just 10 raised to power 4. So in this way, you have converted this large number into this small notation. Let's, before moving to the next value, let me erase it. And now this value is very small. It's less than 10. It starts from 0. And here's your decimal point. So to change this value, you will move your decimal point from left to right. In first example, you moved your decimal from right to left, but here you are moving from left to right. So move your decimal 1, 2, 3, 4, 5, and this is 6. So value will be 1.540 multiplied by 10, and exponent, value of exponent will be equal to the number of time that you moved your decimal from left to right. So you moved your decimal 1, 2, 3, 4, 5, 6 times. So the value of exponent will be 6. But in this case, you have moved your decimal from left to right. So you have reversed your process. So now the value of 6 will be in minus. And in first case, you saw that the value of exponent of 10 was in plus. But here the value is in minus. So whenever you are moving your decimal from left to right, the value of exponent will be minus, and when you will move your exponent from right to left, the value of the power of 10 will be in positive. This is the answer. And conversion of large number. Let's now again, your number is greater than 10, and here is your decimal point. So now move your decimal, because your value is greater than 10, so you will move your decimal from right to left. Remember, whenever the value is greater than 10, you will move the decimal from right to left. So move this decimal 1, 2, and 3. So now the value will be 1.0 multiplied by 10 raised to power 3 because you moved your decimal point 3 times. So again, when decimal point move from right to left, the value of exponent of 10 will always be positive, and it will be positive 3. Let's see what happens in the second case. Write your number. These are 6 zeros, and here is your decimal point. Now your value is again greater than 10. So what will you do? You will move your decimal point from right to left. Here is your decimal point. Move your 1, 2, 3, 4, 5, and 6. So the value will become 1.0 into 10 raised to power. You moved 6 times, so 6. Value is larger than 10, and you moved your decimal from right to left, so the value will be in positive. So value of the exponent of the 10 will be positive. So in this way, you can convert large values by the scientific notation. Similarly, this is again a large value, and here is your decimal point. Similarly, you will move, hence the value is greater than 10, so you will have to move your decimal from right to left 1.0 and count the number 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you moved your decimal from 9 times. So the value of 10, the power of 10 will be 9. Hence, the decimal move from right to left, so the value will be positive. And remember, when you move the decimal from left to right, value become negative. Hopefully, you have understood the concept. Similarly, you can change this value, and this is again greater than 10. When the value is greater than 10, you have to move your decimal point from right to left and count how many times you moved your decimal and multiply it 10 and make it the exponent of the 10, and the value of the exponent will be positive because you are moving your decimal from right to left. Small number, how will you same? This is a small number, so here is your exponent. So when your number is less than 10, what will you do? You will move your decimal from left to right, and your decimal 1, 2, and 3, and 1.0 will equal to 10 raised to power. How many times you move your decimal from left to right? 3 times. So the value of 10 of the exponent will be 3, but you have moved your decimal from left to right, and the value and your number is less than 10, so it will take a minus sign with the. Take another example. Again, your value is less than 10. Here's your decimal point. Here is your decimal point. So now the value, your value is again less than 10. So you will move your decimal from left to right, and 1, 2, 3, 4, 5, and 6. So now decimal will be after 1, 1.0 into 10 raised to power. You move the decimal 10 times, 10 times, and 10 times. 6 times. You move it to 6 times. So you move the decimal from left to right. So when you move your decimal from left to right, the value of exponent will be negative. So 10 minus 6, 1.0. Similarly, you can change this value the same way. You will move your decimal from left to right and put your decimal in front of 1 and see 1, 2, 3, 4, 5, 6, 7, 8, and 9. Multiply it with 10, and now the value of exponent will be 9. Hence you move your decimal from left to right because your value is less than 10. So the value will take minus sign. And similarly, you can convert this value, and whatever you get, you can convert by this formula. So let's move to the units of time. Time is measured in seconds, milliseconds, and microseconds. Milli mean 1,000. So 1,000th of a second is called 1,000th of a second is called a millisecond. Milli mean 1,000th, thousandths. So similarly, you can change this number like this: 10 raised to power 1, 2, 3 by moving decimal points, and its value will be 1 over 10 raised to power 3. And when you will move your denominator above this line and make it numerator, so its value will become minus. So 1 millisecond will be equal to 10 raised to power minus 3 seconds. Another example, micro. Micro mean 1 millionth. Micro mean 1 millionth. 1 millionth. 1 millionth, you can write it 1 millionth. It will divide with 6 zeros, and you can change it to the 10 raised to power. Here is your decimal point. Move it 1, 2, 3, 4, 5, 6. 10 raised to power 6. Value will be positive because you move your decimal from right to left. Now again, you will change your denominator to the numerator, so its value become -6. So 1 microsecond is equal to the 10 raised to power -6 second. Let's take the next example. Nanosecond. Nanosecond is 1 over this large number. 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is decimal point 0, 0. Similarly, move your decimal point from right to left, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So your value will be 1, 10 raised to power 9. The value will be positive because you have moved your decimal from right to left, and your value is greater than 10. And now again, the same way, you will change your denominator into the numerator, and it will become 10 raised to power -9. So 1 nanosecond is equal to 10 raised power -9 second. Similarly, you can change picosecond uh, into this number by using the same method that we followed in the previous examples. So what is time period? Time period, here is our favorite cycle. Time to complete one cycle is called time period. And time period is directly proportional to the wavelength. This is a small wave. The distance from the start of one wave to the end of the other wave is called wavelength. So when a wave is larger, it will take long time to complete this cycle. So the time period of this wave will be greater than that of this one, first wave. So time to complete one cycle is called time period. It is represented by T, and it has same unit of second, millisecond, and microseconds. If you want to calculate the time period, So you have a formula. Time period is reciprocal of frequency. If frequency of a wave is given, you can calculate the time period. For example, if they ask you what will be the time period of a waves of frequency 2 megahertz, so what will you do? Let me erase it. You will use the formula time period is reciprocal of frequency. It means they have inverse relationship. Higher the time period, lower the frequency, and vice versa. So time period is equal to 1 over 2. And when you will divide 1 over 2, answer will be 0.5 microsecond. And remember, when frequency is given in megahertz, time period will be in microsecond. Remember this one. Because mega mean 1 million and micro mean 1 millionth, so they should tally each other. So period is reciprocal of frequency, and time period is equal to 1 over frequency, and it represents in microsecond. So we have already discussed millisecond. 1 millisecond is equal to 10 raised to power minus 3. 1 microsecond is equal to 10 raised to power minus 6, and 1 nanosecond is 10 raised to power minus 9, and 1 picosecond is 10 raised to power minus 12. These are unit of time, and we have already discussed those units. And you can convert these. 1 millisecond mean 1,000th. Similarly, 1,000 mean 10 raised to power plus 3, and when you will move it up, so it will become 10 raised to power minus 3, and you will do the same thing with these quantities, and you can easily change them. So there could be some questions on the SPI board exam, that what will be the period of 2 megahertz, 5 megahertz, and 10 megahertz frequency. So we have already discussed that time period is reciprocal of frequency. So if you want to calculate the time period of 2 megahertz, t is equal to 1 over 2, 0.5, and hence the frequency in megahertz, so the time period will be in microsecond. And similarly, you can calculate time period for 5 megahertz and time period for 10 megahertz. Divide 1 over 5, divide 1 over 10. So it's very simple. Just you need to take care of the units, that when frequency is given in megahertz, the time period will always be in microsecond, not in seconds. They can give you the answer in seconds, but you will not select the any answer that is in second. Always select the answer that is in microsecond. These are the answers. Just divide the frequency by 1 and you will get your answer. Frequency. Frequency cycle per second is called frequency, and we discussed it before that cycle per second is also called hertz. Its larger units are kilohertz and megahertz. Cycle per second is called frequency. Pulse. So we already discussed that one cycle is a wave, and when you add another cycle, it's a pulse. And the distance between two consecutive crusts is wavelength, or two consecutive trough is wavelength, and wavelength will define that pulse is longer or shorter. Two or more cycles is called pulse. Ultrasound pulses are the group of cycles. They are in group of 2, group of 3, or group of 4. So these are the group of cycle. To calculate frequency, this is very important formula. F is equal to C over lambda. So you need to, this formula should be at your finger's tip, because it will use at number of places where F is equal to frequency, C is equal to speed of speed of sound in soft tissue, and that is considered 1.540 millimeter per microsecond. Remember, this is the speed of the sound in soft tissue in the units of millimeter and microsecond. And in meter per second, speed of sound is 1540. So usually, most of the time, hence, when will be millimeter per microsecond? When frequency in megahertz and wavelength is in millimeter, then speed will be millimeter per microsecond. And remember this combination, and don't accept any combination or any unit if any one of them is different. For example, if frequency is 1 hertz, wavelength should be in meter, and speed of light should be in meter per second. So we will see a little while that how these units match each other. So once again, never ever forget this formula, C over lambda. In this equation, frequency and speed of sound has direct relationship. If frequency increases, speed also increases, and vice versa. If speed decreases, frequency will decrease. But in case of human tissues, the value of C, speed of sound, is considered constant, that is 1.540 millimeter per microsecond. So it remains constant, but actually it is not the case. And it's a constant, and this is wavelength. And frequency and wavelength have inverse relationship. Inverse relationship means when one quantity increases, the other quantity decreases. If you increase wavelength, the frequency will decrease. First pulse is definitely a larger pulse because the wavelength is larger as compared to the second pulse. Now, allow this pulse to move a specific point and apply a formula of 1 second. It will take longer time to pass through this specific time, while this pulse will take lesser time to pass this specific point. So this second pulse will have high frequency due to the shorter wavelength, and it will have lower frequency due to high wavelength. We will discuss this a little bit in detail when we will discuss pulse repetition frequency and pulse, how these pulses. However, I will give you an idea that suppose we have a pulse of 3 cycles. 1, 2, and 3 cycles. And we have a second pulse that also have 3 cycles. Its wavelength is larger as compared to the second wave. Now, here is a specific point and apply a formula of 1 second, start a stopwatch and let this pulse pass through this specific point in 1 second. It's a larger pulse, it takes longer time to cross this point. So maybe only 2 cycles may be able to pass in 1 second because it's a larger pulse. Similarly, this is a smaller pulse and repeat this procedure with this second shorter pulse. So it is a shorter pulse, it will take less time to pass and maybe it's all 3 cycles may pass in 1 second. So the frequency of the first pulse will be 2 cycles per second and the frequency of the second pulse will be 3 cycles per second, while both have 3 cycles. Why it is so? It is because of this wavelength. Wavelength increased the size of the pulse and it took longer time to pass a specific point in 1 second. So this is called the frequency of the pulse. Let's move forward. So, and frequency, speed of sound divided by the wavelength. We have already discussed. Frequency is inversely proportional to the wavelength. We also discussed that frequency is inversely proportional to the wavelength. And frequency is directly proportional to the speed of sound. Yes. This is a direct relationship. It's an inverse relationship. And frequency is inversely proportional to the time period. If you remember that time period is reciprocal of frequency, and if you take frequency, if you replace the places of both quantities, frequency will be equal to the time period divided by time period, sorry. Now frequency will be reciprocal to the time period. Here the time period is reciprocal to the so time period is reciprocal of the frequency. Here the frequency is reciprocal of the time period because you have changed it their positions, and actually it is the same formula that we have used before, 1 over f, or it can be written as f is equal to 1 over t. T is the time period. Unit of frequency we have already discussed, cycle per second, kilohertz, kilo mean 1000 and mega mean 1 million, or 10 raised to power 6, and we have already converted it by scientific notation. Gigahertz is equal to this number, 10 raised to power 9. Frequency, speed over wavelength, and remember frequency when wavelength is 0.2 millimeter, what will be the frequency? So if they give you a wavelength, you can calculate the frequency. How will you calculate the frequency? Take the formula C over wavelength, and they have given you the wavelength. So F, C is already known, 1.5 0.4 millimeter per microsecond. It's a constant. So put the value of C, 1.54 millimeter per microsecond divided by wavelength 0.22 millimeter. And when you will divide these, you will get your answer. So like your answer will be 7.5 megahertz. And if the wavelength is 0.77 millimeter, what will be the frequency? The same way the frequency will be C over lambda 1.54 millimeter per microsecond divided by lambda wavelength is 0.77 millimeter. And here is your answer. Almost 2 megahertz will be the frequency. And you see that wavelength is in millimeter and speed of sound is millimeter per microsecond. So remember this combination, that the speed of the sound should be in millimeter per microsecond and the units of wavelength should be in millimeter. So it's very simple. So this formula F is equal to C over wavelength or speed over wavelength is the key formula that you need to remember at all occasions in order to solve these questions. Similarly, they can give you the wavelength of 0.22 millimeter and they will ask you to calculate the frequency, and you will do the same way. They divide the speed of sound by the wavelength, you will get your answer. So we have discussed that speed of the sound is 1.540 millimeter microsecond. And remember this and never forget it. It's often used in, and frequency should be in megahertz and wavelength should be in millimeter. Then speed of the sound will be in millimeter per microsecond. So this combination, again, megahertz, millimeter, and millimeter per microsecond. As far as the definition of sound, speed is concerned, so speed is a distance covered in 1 second. If more distance, a large distance is covered in 1 second, speed is higher. And if less distance is covered in 1 second, the speed is lower. Again, speed is equal to, you can calculate, you can derive value of speed by this formula and take the wavelength on the other side of the equation and you will get frequency into wavelength. If they give you frequency and the wavelength, multiply them and you will get the speed of sound. but in speed of the sound in soft tissue is considered constant. It doesn't change. And we are talking about just soft tissues. Otherwise, medium has effect on the speed. The derived, we have already derived frequency, this formula, frequency into the wavelength. For example, they give you the frequency of 5 megahertz and wavelength 3 millimeter and ask you to calculate the speed of sound. So you will multiply them and you will get the answer. And once again, remember these units: wavelength in millimeter, frequency in megahertz, and speed will be in millimeter per microsecond. Now the frequency is increased. So now the frequency is 10 megahertz and the wavelength is the same, 3 millimeter. Now the speed of sound will be 3 millimeter per microsecond. It means by increasing frequency, speed is also increased. And according to the formula, you recall C over wavelength, that when frequency increases, speed also increases. But it is not the case in soft tissue. Soft tissue speed does not increase, it remains constant. There is a change in the speed, but that change is so insignificant that that is not considered as a significant entity, and it is called as a constant. Wavelength is a distance, and it is measured in millimeter, meters, feet, inches, and you can also derive the formula of wavelength by this main. Take wavelength on this side. Wavelength is equal to C, and now bring it back, C over F. So wavelength is equal to speed over frequency. The same, they have inverse relationship, and with speed of light, wavelength has a direct relationship. That when the wavelength of ultrasound wave increases, the speed will increase. Wavelength will increase, frequency will decrease, because here is the inverse relationship and here is direct relationship. But again, speed of sound in soft tissue, means in human body, is considered constant. So unit of wavelength, you can calculate value of wavelength by using the same formula, that F is equal to C over wavelength. Now if you want to derive the formula for wavelength, what will you do? You will shift the wavelength across the equality sign, and your equation will be like this. Or you can write this: C is equal to F into wavelength. But we need this wavelength, so keep the wavelength here and shift the frequency on the other side of the equation. Now your equation will be C over frequency, or wavelength is equal to C over frequency. C is the speed of sound, and F is the frequency, and lambda is the wavelength. And you see that there is again inverse relationship between wavelength and frequency, and there is a direct relationship between uh, between speed of sound and wavelength. Let's see how this equation goes in solving our problems. So wavelength is measured in millimeter. Millimeter is a smaller unit, while meter is a larger unit. And remember that wavelength will be in millimeter when frequency is measured in megahertz and speed is millimeter per microsecond, millimeter micro or millimeter microsecond. So never ever forget this combination. And if they trick you while giving you frequency in hertz or wavelength in meter, so never choose the answer that in which the speed has millimeter per microsecond, because millimeter per microsecond units of the speed will be when the wavelength will be in millimeter and frequency will be in megahertz. If you change the units, that you convert the wavelength from millimeter to meter and frequency from megahertz to hertz, so speed of sound will be changed from millimeter per microsecond to meter per second. So never be tricked by the changed units in the board exam. So what is the wavelength of the 2 megahertz, 5 megahertz, and 10 megahertz frequency? So we have already calculated the equation, derived equation of the wavelength. That wavelength is equal to C over frequency. So what will you do? C is already known, that C is the speed of sound, that is 1540 millimeter microsecond. So put 2 megahertz value of frequency and divide it, and you will get the answer. Similarly, for 5 megahertz, you will use the same formula, and speed of sound is known, and divide it to the 5 megahertz frequency, and you will get your answer. So it's very simple. The one thing that should be kept in mind, the units. Never be tricked by the units. Units should be tally each other. And remember regarding with the speed of sound or anything else. So these are the wavelength of wavelength for 2 megahertz. The same way you will divide frequency with the speed of sound, and you will get your answer. Divided And the graph, there are different graphs to show the different quantities. And this is x-axis and y-axis. And x-axis and y-axis are also used to show the relationship between the different quantities. Please subscribe my channel and like this video. Thank you very much.